Please enjoy this week's episode.
Our next speaker is Dr. Vincent C. Giampapa. He is a world-renowned medical doctor, inventor, and surgeon specializing in anti-aging medicine. He's one of the first board-certified anti-aging physicians in the world. He's a co-founder of A4M and the first president of the American Board of Anti-Aging Medicine. He's written books, et cetera, et cetera. He was nominated for a Nobel Prize in both 2014 and 2015 for his groundbreaking research into cellular restoration technology. And I think what speaks most to him being like the pioneer OG guy is he actually coined, and I talked about this yesterday, he coined the term anti-aging. I mean, he's the first guy to do that. It's kind of a big deal. Anyway, he's also a very cool guy. He's got some wild stuff going on in Costa Rica. I don't know if he's going to talk about that or not, a whole movement over there. But let's bring out my good friend and the esteemed OG anti-aging dude, Dr. Vince Giampapa.
Thank you, Greta. Thank you, honey. Pleasure. Okay. Let's go. I don't need that. Oh, I got that. Okay, great. Well, it's a pleasure being here with everybody today and all these unbelievably intelligent doctors and dedicated people. It's really stimulating. But first I'm going to share with you a secret before we get started, which I think is going to enhance the health span and longevity of everybody in the room. But first, a few facts. You know, the information we have about aging and related technologies doubles every 3 months, which means in 3 years from now, we're going to have 6,000 times more information than we have right now. Did that sink in? 6,000 times more information. So the whole thing here is, what do we do with that? Well, in the next decade, we're going to see such unbelievable advances in AI and accelerated rate of new information. And following that, shortly after, quantum computing is going to come on board. What's going to happen is we can't even imagine the new information, the new information we have about how we age and the new technologies that are going to be around. So what's the real secret I'm going to share with you? The real secret is the following. Don't be dumb enough to die in the next 3 years. So that's all I can tell you because it's all coming very, very quickly. Okay. So Dr. Jordan just spoke about that central aging clock, so I'm not going to go into detail about that, but I'm going to talk about how we have different types of clocks in different levels of our body. So the human body has multiple biological clocks. The circadian clock is one of the key ones that kind of really organizes the processes that occur to us throughout the whole day. But each one of these clocks have a very complicated network of genetic, if you will, genetic pathways or genetic wiring. Ultimately, they all regulate how the body ages and how it functions. So the central aging clock, which you just heard about, which is located in the hypothalamus, really sends information to every one of the cells in our body, which I look at and many other people look at as peripheral aging clocks. Those are our stem cells and our body cells. Now, during the day, our basic lifestyle has a major impact also on our peripheral aging clocks, which are our cells. And that information gets transmitted to us via epigenetics, or what our body does, and the ability is to either turn on or off different genes based on our lifestyle activity, our food, and even our stress levels. So the key thing here is we have to start thinking the human body basically in the fact that it has different levels of, if you will, clocks that regulate our function and our aging. So the aging clocks have a different hierarchy. We have the central aging clock, which, as Dr. Jordan was talking about, really is focused on all the nuclei in the floor of the hypothalamus that regulate pretty much everything from sleep to eating to our hormonal levels. We have the peripheral aging clocks, which are impacted by the brain, the central aging clock. And then we have inside our peripheral aging clocks our genetic clocks. So I got thinking one day, I'm saying, well, for all these clocks that are there, how could we maybe manipulate one of these clocks, like the genetic clock, and maybe engineer something that would allow those genetic clocks to work better? So that's what happens when you have a crazy mind that's always looking at things a little bit differently. So the peripheral aging clocks, stem cells and somatic cells, we all know about, we have 100 trillion cells in our body. Each one of those cells has 3 feet of DNA. So there's enough DNA in one cell to go from the Earth and Moon back again about 5 times. So imagine all of that stuff squished into one of those 100 trillion cells. What controls those cells are a number of these things. These are external factors. For instance, the plasma in our body. And one of the things we do at RMI is our big focus is to clean that plasma. And I'll give you a little analogy. Imagine if you had a new fish tank at home with these beautiful tropical fish. What would happen if you didn't change that water in 6 months? We all have that image, right? So what would happen is those fish would not only not do well, if they did survive, they would function suboptimally. Well, I hate to say this, but every one of you has had your same plasma since you were born. And what's happened to that plasma is it's now actually holding all the compounds that the aging cells in your body are making, all these pro-inflammatory cytokines, growth factors. It's holding pieces of contamination from the environment, from vaccines, from everything that your body's exposed to. So instead of being really nice and clean and allowing your stem cells and your body cells genetically to work optimally, they're unable to do that. So one of the key treatments today, and more information is coming out daily, is plasma, as a whole technique to clean your plasma, restore it with crystal clear fluid, and add new proteins to it, like albumin. And that's something, I've had that done 3 times, and I wish I had my picture here, because when I hold up that bag, it was pretty scary. So what happens to our clocks, the environment around them, senescent cells, okay? So what happens as our telomeres shorten, the actual genetic clocks stop you from making new cells, and then that cell sits there and not only starts producing pro-inflammatory compounds, but those compounds cause your body and stem cells to age more quickly. We all know about free radicals. That's produced. We produce them kind of like the exhaust from a car, and if you don't have a muffler, it's pretty bad. Well, once we hit about 30, the mitochondria in our body, where all of this is going on, energy is going on, no longer able to buffer all those free radicals. So we end up with a lot of DNA damage. And DNA damage is one of the first hallmarks of aging, because it disrupts, that damage to our DNA disrupts our genetics that we're born with. We have things called retrotransposons, big fancy name. Now people don't really know about this, but in our community they're becoming more and more popular, because these little viral genes crept into our genome hundreds of thousands, if not millions of years ago. They helped us adopt the changing environment around us. And they're sitting there silent until we're about 60, 55, 60, when the inflammation rates in our body get so high, they get activated. And now we know they're another major reason why we age quickly. The more of these things we have activated, the less active and the less functional are our stem cells. So the genetic clocks, let's take a look at these. Within our peripheral clocks, they're controlled by a host of different processes. And a lot of this is medical terminology, but basically, in order for a gene to get turned on or off, the body actually just moves a little molecule called a methyl group, a CH3 molecule. So when you're young, most of your genetics, you do not have, at the beginning of your DNA, a lot of methyl groups. And as every decade goes by, you have more and more of these methyl groups moving to the start portion of your DNA, and it gets turned off. So are there things you can do to undo that? Yes. Okay, there's certain compounds that will actually start to remove those methyl groups, so your young-oriented genes can get turned back on. DNA acetylation and histones, these are just fancy names for a portion of the DNA that actually looks like a slinky toy. Anybody here remember slinky toys? All right, or a spring. So if you stretch out a spring, there's more spaces between the spring. When that happens in your DNA, okay, the DNA is able to actually start making proteins that you used to have when you were young. And when you're young, that portion of your DNA is spread out, and all these beautiful proteins are made to keep you looking well, feeling well, thinking well. So as you age, if you think about squishing that spring together, the spaces decrease until there's no space, and what happens is your body shuts off making these youthful proteins, and another group of proteins become active and cause you to age quicker. So all of these things happen inside your cells at the genetic level. And the whole thing is what can we do now to really start to undo that process? Because this is where the aging process really starts, at the level of our genes. So my whole focus has been on stem cells and the genetics around stem cells. So stem cells are a very interesting thing. We have a regenerative system, which most people don't even know about, just like a cardiovascular system, a muscular system. And that regenerative system is made up of 3 types of stem cells. Stem cells that make your immune function, stem cells that are designed to repair and restore your blood vessels and regenerate new blood vessels, and stem cells called mesenchymal stem cells that can literally turn into muscle, bone, cartilage, or brain tissue. So we're born with a fixed number of those stem cells, and we're going to take a look at what happens as we age, because that regenerative system is something that starts to work not so great. Now, Dr. Jordan showed this slide on the left, and if you take a look at this, the immune function is really optimal when we're in our 20s, even up to our late 30s. But around our 40s, we start to really lose the effect of our immune system. And if you take a look at the other slide, this little purple line, that purple line represents a drop in your total stem cell numbers, particularly your hematopoietic stem cells, your immune stem cells. If you take a look at the purple line, which is on the left here, which is where you start to see a big increase in diseases, you're going to see that is pretty close to the senescent cell line on the other side. Those are the cells that accelerate aging. So what we started to see is where these 2 lines cross is when you start to age very quickly. You've lost stem cell numbers. You've started to accumulate these age-accelerating or senescent cells. And when you really put these 2 graphs together, you start to see that how important maintaining your stem cell numbers are really, really for your future health and longevity. So let's take a look at this. We're all born with a fixed number of stem cells. Some of us with more stem cells than the other ones. Those are the lucky people. But most of us about the same. To go from a baby to an 18-year-old adult, you used up 60% of your stem cells. And that's called, we're not really aging, it's developmental. We call it developmental aging. So you turn into a mature adult. From 18 to 30, which is all of these key productive years that most human beings, where they're at their peak cognitive function, physical function, mental function, everything's working great. You still have enough stem cells at 30, despite the fact you've used up 75% of your stem cells. Now, to go from 30 to a 60-year-old is where it really starts to get scary. And if we remember that past graph that I just showed you, at about 55 to 60 is when these 2 things cross, the senescent cells and the stem cells. And that's where you start to age very quickly. You start to notice you're losing muscle mass, you're not thinking as well, you're starting to get sick more often because you've lost all those key stem cells, hematopoietic stem cells that maintain your immune function, endothelial progenitor cells that make sure your blood vessels are open and functioning well, they get nutrition out and all the toxic materials out. You have very little mesenchymal stem cells, so you can't maintain your muscle mass or repair damage to your ligaments and cartilage. So all of these things start to happen. And when you hit 60, 55, 60 is when it really gets bad. So the question here is, what can we do? Now, loss of stem cells are the 9th hallmark of aging, but hallmarks from 1 to 8 all lead to loss of stem cells. So the human body, the aging rate and function is largely controlled by our regenerative system. And basically, it controls both the numbers and the quality of those stem cells. But the activity of those cells is really linked to specific genes. And at different times in our life, there's like a genetic clock. Each one of those 100 trillion cells has about 3,000 genes in general that do different things. So when you're young, this group of genes is active. A few years later, those get turned off, and another group of genes get on. Those get turned off at middle age, and a third group of genes in old age get turned on. But they're all still there, but they go from being turned on to turned off, and they go through this whole reprofiling. So the whole thing here is, how can we fix that within this particular regenerative system? Okay. So we all started to think at our RMI, at our institute, what are the next advances in aging therapeutics that might allow us to restore lost function, enhance our health span, and our longevity? And how would we do this? So let's take a look at the effects of the loss of specific gene activity and the number and function of quality of stem cells has a big impact on 4 major areas, which we all will go through. We lose muscle mass, okay? And no one likes to hear this, but you see a lot of people in nursing homes who can't even get out of their chair because their muscle mass has been lost due to the processes we've just looked at. That's called sarcopenia or frailty. Dr. Jordan talked about what happens with age in our memory. So we have cognitive decline. Immunosenescence is the loss of our immune function. Those are directly related to hematopoietic stem cells, and cognitive and sarcopenia related to loss of mesenchymal stem cells. Cellular energy loss. So you notice you're not able to go out to 2 o'clock in the morning and get up the next morning at 7 and feel like you did when you were in college, because you're not making ATP, and your mitochondria that make that energy molecule, you've lost about 80% of those. So how do you get back mitochondria? Well, guess what? When we manufacture umbilical cord stem cells in Costa Rica in a FDA equivalent GMP ISO 7 facility, when we infuse people with 100 million umbilical cord mesenchymal stem cells, the mitochondria from those super young cells actually migrate into your cells. And your cells now are flooded with a lot more energy. And it stays like that for a long time. So these are some of the newer things we're now learning about. How do we increase cellular energy? But the real thing is, how can we enhance the gene function that we've lost? And so now we're going to move into, I would say, not sci-fi, okay, but close to it, because it's not really sci-fi, because there's already people who have enhanced genes. They're GMO people. Okay, so gene-enhanced stem cell function and somatic cell function is probably going to be the next quantum leap to keep people healthier longer. So what are some of the key questions we have to ask? Can we enhance a specific gene to restore a lost function, like loss of muscle? Can we do this without altering the genetic material that we were born with? Well, we don't want to. The big scare is if you start messing around with your own genes, what could be the long-term impact? Are we able to alter the cellular clocks that we're born with? And is there a way to solve both stem cell loss and both numbers and function? So can we do this to improve both our health span and our lifespan, along with fixing some of the defects? And I believe the answer is yes. So if we take, for instance, a specific gene, okay, and there's ways of actually inserting that gene into a stem cell, and we can either use a viral shell, not the actual DNA of the virus, but the shell that viruses make, stick a gene in that, and literally culture that with a cell, we end up with a new piece of genetic material that's not really incorporated into our DNA, but is sitting in the nucleus making a protein. It's kind of like, gee, we kind of like created a mini artificial chromosome. So Has that been done? Oh yeah, it's not only been done, but the FDA has approved I think it's over 40 cell-enhanced gene technologies. Most of them are being used for cancer treatments or severe diseases. Could we create this new artificial chromosome designed with a gene activity that we need? Okay, and again, these viral vectors are already being used in humans. They've been shown to be safe. They're FDA approved, and they're actually available now, but that technology is now just starting to be used for cell enhancement. Attenuated adenoviruses are the ones that are being used in most of these new products, where you can load a limited number of genes. And then these other vectors, cytomegaloviruses, which have bigger shells, can load a number of cells, a number of genes, 5, 6, 7, 8, or even more genes. And I'm going to show you why that's going to be important. Now, plasmids are another way you can get genes into a cell. They're back from basically a bacterial shell, but plasmid gene enhancement doesn't really last that long. It might be 10 months, 12 months at the most. So the question is, can we load a vector with more than one gene? And the CMV virus right now seems to be the one that's most promising. So let's say we took a specific, I'm going to say hematopoietic stem cell. We put in the gene to extend telomeres. It's called hTERT. So instead of, you saw that curve, that yellow curve you saw around the 40s, you start to lose your total number of hematopoietic stem cells. But if that hematopoietic stem cell had a telomerase gene, that curve would flatten out and stable. So your immune system wouldn't continue to decline. Specific stem cells for specific purposes. I just talked about hematopoietic stem cells with an hTERT gene. That very well could be the cure to immunosenescence in the very near future. Mesenchymal stem cells are very special. They have a receptor site that bonds to certain other compounds inside your blood vessels. And when you use ultrasound, like Dr. Jordan just said, these compounds on the inside of your blood vessel get activated, and the mesenchymal stem cell literally sticks to that, delivering its contents inside the cell, including the klotho gene, to make klothoproteins, which actually will enhance your memory and brain function. Will also help boost those aging clocks that Dr. Jordan was talking about. So what happens if we all work out, and in our 60s we notice we work out twice as hard and we make less muscle? That's because your body at around 45 starts making myostatin that inhibits muscle growth. Okay, so if we add follistatin to a mesenchymal stem cell and infuse that or inject it, we can selectively augment muscle loss, or we can give it intravenously and enhance muscle growth through your whole body. Well, one of the biggest problems we have is frailty and sarcopenia. This may be one of the ways to go after that. And there's a host of other things. So if we look down at the bottom, here we'll see all 3 stem cell types. So when we collect stem cells, we collect all 3 of those stem cell types. If we were to add, for instance, hTERT to all 3 of this conglomeration of stem cells, all our stem cells would be able to make copies of themselves for dramatically longer periods of time, helping to maintain most of the function that we lost. So a key to the hallmark of aging, okay, gene-enhanced stem cell therapies may be the choice of the near future, offering another option along with stem cell reprogramming. Now, stem cell reprogramming is been underway for quite a long time. There's things that we call CRISPR-Cas9, where you can take one gene out and selectively put another gene in. That's already FDA approved for a number of things. There's another form of CRISPR-Cas9 called TALEN, which has it's another technique to actually move genes around. There's epigenetic reprogramming, where we actually use repurposed medicines. Now, there's medicines that we're finding now can do almost the same thing as the Yamanaka factors, which are genes that you have to put into your cells. So again, this is all due to the AI explosion and the access to new information. But here's the big thing. Perhaps we can insert new genes to restore the original function we had when we were young that we lost. Make more muscle, be smarter, keep our immune system stronger. So if we reprogram stem cells, and which we did in 2014 and 16, we took 80-year-old stem cells, turned them back into 30-year-old stem cells, and we follow those patients for a number of years. That data, I think, is going to come out shortly. I know a number of the patients personally they're in their 80s, who have unbelievable health and function. So epigenetic reprogramming is probably the safest way to do this, because that's what our body does every day. Exercise, diet, and all the lifestyle habits actually alter and turn different genes on and off. But what happens if we were to do that treatment and infuse these new reprogrammed cells? They would literally start to restore the whole body, regenerate. It would take probably 4, 5, 6, 7 years before the full body was able to function more optimally. With a gene therapy, within months or less, you can start to see more muscle growth. You can start to see an immune function. So basically, cell-enhanced gene therapies may be the actual treatment of choice to undo the damage that's already occurred in us. So what if we use the gene-enhanced cells prior to when most of the aging damage occurred? So I had my children's stem cells collected when they were in their 20s. They're now in their 40s. They're starting to get their stem cells back to avoid this deep cliff drop-off of these stem cells. But what happens if we had those stem cells and we were able to give them all 4 of these genes: enhanced muscle mass, enhanced cognition, enhanced immune function, more energy, and we started that therapy maybe at age 40, 45, those people wouldn't accumulate the damage that we all have done. They would age. What would that do to their health span and lifespan? And from a theoretical point of view, it may be the way this goes in the future. So one of our colleagues, who's here in the audience, has had the faith to become the first patient to prove this concept is effective. And Liz is sitting here. She's pretty hard to, she's not hard to miss. But she has had the faith to believe in this technology. If you take a look at her picture from 2015 to 2020, you're going to see somebody who looks not only younger, but more vibrant. And even the 2024, again, you're seeing the effects of somebody who has all 4 of these genes. Okay. Clotho, she's smarter. Her cardiac and renal function are better. Her muscle mass has increased, documented on MRIs. Her telomeres are up to, I think it's 20 years younger or longer than they were when she started. So all of this data, she's been collecting all this data. So what you're starting to see is maybe, just maybe, the technology is already here to do things that we didn't think was even possible before. So let me remind everybody, we're all dying from a fatal disease. Everyone in this room, you were born with a fatal disease, and it's called aging. Okay, we can just accept that, and we can use all the little ancillary things we know do help and slow it, or we can use that information that's now available to create a whole new paradigm. So the most important thing you could do today is really, I believe, is get your stem cells collected. So what does that mean? At RMI, and we are in San Jose, Costa Rica, the treatment we recommend to all our patients is to have their stem cells collected and stored, placed in -80-degree centigrade, where all 3 of those key stem cell groups stop aging. So, yeah, you can take a part of your body, put it into cryosuspension that doesn't age anymore, and you're aging out here. And that's what's been going on for a couple of decades. Collecting and storing stem cells is an FDA-approved process in the U.S. The machine that collects and stores them is an FDA-approved process. But guess what? You can't get your cells back because you're not allowed to take your own cells back because they're not approved to do preventive things. It's approved to treat cancer or certain autoimmune diseases, but not to help keep you healthier longer. Now, does that make a lot of sense? I guess if you're the FDA or insurance companies, it makes a lot of sense, but not to us. Okay. So the secret here is to take advantage of this type of thing, because even now, without gene-enhanced cell therapy, The animal studies and early human studies are showing if you get back a small portion of your stem cells once a year, like a blood transfusion, that steep curve and loss of function in both your immune system, your regenerative system, your blood vessels slows down. Okay? It gives you healthier quality time. So bioinsurance is really what we call this. And when we collect people's stem cells, you'll see, let me see if I can get this video to go. Nope, I'll go back. But you sit in a chair like this, it takes about 2 hours, but we collect billions and billions of stem cells that are released by just an injection for a couple of days, a little tiny, like insulin syringe injection with a compound that's FDA approved to do this. And so what happens, that machine collects billions and billions of stem cells for your future use and for whatever future technologies are going to evolve. Now, here's one thing that most people don't realize. That's your first treatment. So when people get collected, their body is flooded with billions of hematopoietic stem cells, mesenchymal stem cells, all the subsets of stem cells. They circulate for over a month at very, very high levels and actually are repairing and restoring the damage that your body has collected up to that point in time. And if you've had an injury, you're going to notice that if it's your low back or your shoulder, it's going to be more achy because those stem cells are going to the areas that have been damaged. Now, so aside from being treated the first time, your first treatment, now you have billions of cells to use on a yearly basis to potentially be reinfused to mitigate one of the most important hallmarks of aging, which is loss of stem cells. Okay. So within our lifetimes, we will see advances in technology that will change everything, things we cannot even imagine. We will see the emergence of AI, which will rapidly increase the information we already have, which is tremendous. But with the emergence of AI and quantum computing, basically we'll be able to, within the next decade, or I'd say 6 to 7 years, we'll be able to do virtual research studies. So today, to do research on cells, you go to a lab, you have to have lab technicians, it's a very expensive and time-consuming process. In the next 6 to 7 years, we'll be able to do research that takes weeks and months and minutes at a fraction of the cost, a fraction, which means we're all lucky to be alive at this point in history because this is really the renaissance of medicine. This is where all the changes are going to happen so quickly, you're not going to even believe what's going to be available. So let me ask you a few other questions. Should we and our patients have the right to choose what therapy we want? If you had the option right now from your doctor, your anti-aging doctor, say, we're going to give you, your immune system is really crummy. We're just going to take some of those stored hematopoietic stem cells. We're going to put the telomerase enzyme in there and give you back 1 million of those. So you're not going to get sick as often. You're going to feel better. You're not going to really have any of those autoimmune diseases. Is that something you'd want to do? Probably yes. Or if you're noticing you're going to the gym and your muscle mass is decreasing and it's harder to walk up steps, your doctor might say to you, well, let's take out some of those mesenchymal stem cells and we'll just have them fused with some follistatin, give you that. And in the next 4 to 5 or 6 months, you're going to gain back your muscle mass and your independence. You're not going to be stuck in a wheelchair or a chair to really have somebody help you get up. This is where it's all going.
And I'm going to RMI, oh me, oh my.
Okay, well, I'm
Costa
finished.
Rica and
2
get
seconds.
collected.
So as a special group of physicians, we need to remember the real voyage of discovery consists not in looking at new landscapes, but in having new eyes. Is that where you all want to be when you're 80, 90, or 100? I'd say yes.
If you are enjoying this program, please hit that subscribe button, or even better, leave a review. Your support makes it possible for us to create the quality programming that we're continually striving for.
Can I start? Is it recording?
It's already recording.
Oh, sorry. This is for general information and educational purposes only, and it's not intended to constitute or substitute for medical advice or counseling. The practice of medicine or the provision of health care diagnosis or treatment, or the creation of a physician-patient or clinical relationship. The use of this information is at their own user's risk. If you find this to be on the value, please hit that like button to subscribe to support the work that we do on this channel. And we take your suggestions and advice very seriously, so please let us know what you'd like to see on this channel. Thanks for watching, and we hope to see you next time. You should say that.
No, that's good. That's for you to say. I think that's very good. Do you like it? You want to do it one more time, or is that good? I think that was good.
Yes.
All right.
You need to save the recording.